Hi everyone, this is EpiCool and we're gonna do a demonstration of the functionality and user interface of our C cubed system.
Alright, so the first thing we have to do is on the interface side of the device we need to set the parameters for the cooling that we want to do. So by doing that we can enter any key and the device will start listening to us. And you can use the set command to set any of the following parameters. You can set the amount of time that you would like to cool for, the intensity of which you would like to cool, so you can set anywhere from a 0 to 1024 value, and that's just a scaled intensity of cooling. You can set the refractory period, which is the amount of time after a cooling cycle for which you cannot trigger another cooling cycle. For the thermistor, you can set the minimum temperature. A cooling cycle will not occur if the temperature is below the minimum threshold temperature. You can also set the seizure threshold. The higher the seizure threshold, the more likely a seizure is to be detected. You can also set we have two different types of detection algorithms. We have a basic detection, which is just a basic thresholding algorithm, and then we have a more complex detection, which uses thresholding over a period of time. So I've already set up all the parameters for our current testing. So I'm going to go ahead and send the activate command, and now the device is activated. So what the device is currently doing is it's looping over, listening for either input from the serial monitor to listen out to the computer to see if it has any commands for it. It's also listening out to the user switch to see if the user is trying to signal for a seizure. And it's also every 5 seconds for 1.5 seconds. It is sampling at 250 Hertz from the neural electrode, and then it's doing some processing on that to see whether or not a seizure is likely.
Okay, now we're going to demonstrate the functionality of our device. In order to show you when the device is cooling or not, what we have here is a thermistor that we've attached to the Peltier cooler. And that thermistor is attached to a lab UVI that we've written, and that just shows the temperature over time. And so one way that the device will start cooling is if it detects a signal that is seizure signal through the depth electrode. And since we don't have a human patient to demonstrate this with, what we're going to do is simulate seizure data and non-seizure data using a function generator. So our research showed that seizures occur in a range of about 8 to 42 Hertz, and seizures are about 10 millivolts, whereas non-seizures are lower frequency or much higher frequency, and they're about 5 millivolts. And so ideally, if we were to input a sine wave within the seizure frequency and amplitude range, the device will detect it as a seizure and start cooling. So let's do that.
There
Okay,
it
the
goes.
temperature drops rapidly, which means that a seizure has been detected and cooling has started.
The reason it took so long in this case is because the device is only reading from the neural electrode every 5 seconds. So we just turned it on at an inopportune moment.
And so now we want to input a non-seizure data to show that it doesn't start cooling when you do that. So here it is. And as you can see, the temperature stays about the same and does not start to cool. Another way that we can induce cooling is with our manual input. So we have this magnet here that if swiped over the switch would start cooling like that. Oh, and you can see you can see that the temperature drops very rapidly, showing that it's cooling. Because our cooling cycle right now is 6 seconds, we can't really demonstrate this, but another swipe of the magnet would stop cooling as well.
And in the case of the neural-induced seizure as well. So you can stop a seizure, the user can stop a seizure, whether or not it was user-induced or neural electrode-induced.